class. So we are going to introduce coordination compounds. So what is coordination compound? First, I am trying to make you to understand. For that, first we are going to perform simple experiment. From the experiment, what are the observations we are finding? So we are going to record all that observations. And then from the observation, we are going to understand what is coordination compound. We are going to understand. In this, first of all, we are going to perform the test for ferrous sulfate. You take ferrous sulfate salt. For ferrous sulfate salt, do the test for ferrous and sulfate. So the first salt taken is nothing but ferrous sulfate.
So now you see that we are just doing the test of ferrous sulfate. So can anybody tell me that which type of salt it is? Simple or the complex?
Simple.
This is a simple salt.
You don't ask simple salt. Simple salt will come back here. Just confirm.
The test of iron, that is a ferrous we are doing here, and then after the sulfate. Okay, and then you all please observe that what are the color changes taking place during the test. So here is the solution of ferrous sulfates. You all can see. Now I am taking the test tube and adding few ml of this solution. And here it is the solution of the potassium ferrocyanide, as you can see. Then I am adding this solution and you will observe the color change. Okay. See. This is the test of ferrous. As we can see that the light blue color is formed. That means we can easily observe the colored precipitate formation during this test, and this is the test of ferrous. Is it clear to everyone?
Yes.
Okay. Now we'll perform the test of sulfate.
1 minute. No, this is just you do it right. Now you see, we perform the test for the salt which has been taken is nothing but ferrous sulfate. For ferrous sulfate salt, when the test is performed for the ferrous, it gives answer for the ferrous. Now we are going to do the test for sulfate.
Again I am taking the same. So few ml of the ferrous sulfate I have taken this test tube. Now I am going to add, this is the solution of barium chloride, as you all are very much familiar about the salt, and I think कि आप जानते भी हैं color आएगा. You see.
What color precipitate is obtained? White color.
White.
Okay.
White PPT forms.
Is it answering for sulfate?
Yes. So if I am just.
Thank you, madam. Next.
So this is the test of sulfate. Thank you.
See, when ferrous sulfate salt is taken, it gives answer for ferrous and sulfate. Now we are going to take more salt. More salt is nothing but ferrous ammonium sulfate. For this ferrous ammonium sulfate, first we are going to do the test for ferrous.
Again. So this is more salt, and as you all know that it is in a solid form, but I have already prepared the solution, and I am taking a few ml of this solution in the test tube. Here it is more salt, and again for the test of the ferrous, I am going to add potassium. You see, it is clearly visible the test of ferrous, right? Now what we will do? We will do the test of ammonium as well as the anion, that is the sulfate. So this is the test of ferrous. Now we'll come to the next cation, and this is ammonium. taking few ml of again the Mohr salt, and then I am going to add a small amount or the few ml of the NaOH solution. Then we will add Nessler's reagent. So you see, see. Now you see that the brown PPT forms. Nessler reagent we added in the solution of the Mohr salt, and this is the test of ammonium. I hope it is clear to you all that in the Mohr salt two cations are present. One is ferrous and the next one is the ammonium. Then we'll come to the anion, and this is what? Sulfate. So now I am performing the test of the sulfate ion. Small amount of or the few ml of the Mohr salt solution again, and then I am going to add the BaCl2 solution which is already prepared here. You see, this is the white precipitate form. That means the Mohr salt gives results of all the three anions, that is the two cation and the one anion, right? So now we come to the third one.
You perform the experiment, let us record the observation. We will come for explanation later. So more salt has been taken. The more salt, we checked the test for ferrous and test for ammonium and test for sulfates. It gives answer for all the three. We record it. Next, we are going to do the test for potassium ferrocyanide. For potassium ferrocyanide, from the name itself we can make out it has potassium and ferrous and then cyanide. First, just you do the test. We are going to do the test for potassium, plain test for potassium.
This is a potassium ferrocyanide. So dry salt. Dry salt is taken, and then 1 drop concentrated hydrochloric acid. Just paste it for flame test. Actually, it was performed in burner and it was positive.
Try to glass it up. Just
take more salt, take कुछ सा salt. ज़्यादा ले लो salt.
Light pink color is there. Appropriate salt.
और थोड़ा salt डाल ज़्यादा टेस्ट
And then this putting this one.
इस पे glass road पे salt ज़्यादा ले लो. Liquid तो चल रहा है.
The upper portion is pinkish.
Pinkish.
The upper portion is pinkish.
Yeah, upper portion is pinkish.
नहीं small sparks.
Sparks with pinkish color. Yellow sir.
हाँ, yellow से pink.
Okay. gives answer for potassium in the claim
और
test.
नीचे ले जाओ
Blue portion में कहीं भी.
हाँ ऊपर जो है हीट कम
नीचे ले जाओ
बहुत कम आया
Fine.
in flame it is clearly pink yes
Yeah.
Yeah, blue
Emulsion
flame
burner,
में
emulsion
answer under
burner
the.
we got
Yes.
we got pink color. Good. Now, Mandel sir, just you do a test for ferrous and cyanide. First do the test for ferrous.
this is potassium ferrocyanide solution potassium ferrocyanide solution and for ferrocyanide for ferrocyanide original solution plus potassium ferrocyanide. So it is itself potassium ferrocyanide. And if it is potassium ferrocyanide is added again, so there will be no color change. That means if it was Fe2 plus, then the color should be blue precipitate. But in aqueous solution of ferrocyanide, if potassium ferrocyanide is added, there is no change. That means Fe2 plus is not free. Fe2 plus is not free.
Correct. Do the test for cyanide ion.
For cyanide ion, salt is taken, then dilute HCl is added. Dilute HCl, salt is taken, then dilute HCl is added. And then ferric chloride solution,
One drop of electron.
1 drop. One drop. So it is Prussian blue color.
चेक कर लो इसी को चेक कर
So actually this is the taste for ferric ion. Ferric FeCl3.
Just say when you push on
Jump inside. After that.
It's okay, sir. Color तो आप explain करो.
So it is actually ferric chloride and potassium ferrocyanide. So taste for Fe3 plus है. Ferric ion. Ferric chloride का Fe3 plus. Ferric chloride में Fe3 plus है. That will actually react with potassium ferrocyanide to form ferric ferrocyanide. So this is not the taste for cyanide ion. For cyanide ion it should be blue color or greenish blue color. So cyanide का taste जो है इसमें नहीं आता.
Thank you, friends. So all our observations are over. So today's experiment, 3 salts were taken. For the 3 salts, different tests were performed. So after performing the test, we recorded all our observations. The first salt, ferrous sulfate. The ferrous sulfate, it answers for ferrous and sulfate. It has one type of cation and one type of anion. And what it should be called? Simple salt. So it is nothing but simple salt. Simple salt. Let us write its formula also. Ferrous sulfate. So to do it get cancelled, so we are going to write the formula ferrous sulfate. You know very well, it is nothing but FeSO4. Fine. Now let us come to the Morse salt. The Morse salt, see, it answers for two cations and one anion. In any salt is a mixture of two simple salts chemically. Chemically, when two simple salts are mixed, it should be called as double salt. So Morse salt is example for double salt. Let us write its formula. It is nothing but a mixture of ferrous sulfate and ammonium sulfate. The ferrous sulfate, FeSO4, and ammonium sulfate, NH4 twice SO4. How many molecules of water? 6 H2. It's nothing but Morse salt. Then potassium ferrocyanide. In potassium ferrocyanide, potassium, ferrous, and cyanide is there. So for these three now, of course, it also same appears like double salt. See there, in double salt also know there are two cations and two or more cations and anions. So two simple salts are mixed. Here also two simple salts are mixed. But potassium ferrocyanide is called as coordination compound. So why it is called coordination compound? That is our important discussion. First of all, for these three salts now you see that when they are dissolved in the water in aqueous solution, let us see about is constituent ions. Constituent ions in aqueous solution. Similarly, identity. Identity in aqueous solution. See that when ferrous sulfate is dissolved in water, it gives both ferrous and sulfate ions. That means it gives all constituent ions. Then if you come to identity in the solution, is it losing its identity completely? In solid state it has identity. Ferrous and sulfate are together, it's called as ferrous sulfate. But in solution what happened? Both the ferrous and sulfates are separated, so it loses its identity completely. Why it loses its identity completely? Because it undergoes complete dissociation. Dissociation is complete. Let us write the equation for this. Ferrous sulfate in aqueous medium, it is dissociated into Fe2 plus aqueous plus sulfate SO4 2 minus ions, aqueous ions. And then the same way if you come for double salt, this is called as double salt, Morse salt. For Morse salt, now you give me the answer. Okay. Is it giving all the constituents in the solution?
Yes.
I'm not getting the answer. Yes. It gives answer for all the constituent ions. So it gives answer for all the constituent ions. And then you come to the identity. The same thing, it loses its identity completely. And again, because it undergoes complete dissociation. Now if I write the equation, dissociation equation for this, the dissociation equation for this is nothing but Fe2 plus plus NH4 plus plus sulfate ion SO4 2 minus. Of course, the equation is not balanced. It's not a. We will see later on. It's not much important.
टू लगा दो अमोनिया का सल्फेट का टू लगा दो
Ammonium 2,
सल्फेट
sulfate no 2.
इट इज डन
Oh, it's balanced. So this is second part. It also gives all the constituent ions, and it loses its identity completely in the solution. Now third salt, if you come to the coordination compound, the coordination compound you see that we are getting the answer for potassium, but we are not getting the answer for these two ions. Ferrous and cyanide ion, we are not getting the answer. That means that two ions are not free in the solution. These two ions are together. Therefore, if I come to the explanation part, it does not give all the constituent ions. No. And again, it does not lose its identity completely. Dissociation also partly dissociated. So dissociation is not complete. So if you write the equation for this, potassium ferrocyanide, since these two ions are arrested, both are together, we are going to write Fe CN6 to a 2 minus, sorry, 4 minus, no? 4 minus, and 4K plus. If I write the dissociation equation, 4K plus
Left
the
side.
P, CN6, 4 minus. This is called simple ion.
Left side charge at all. Left side की charge at all.
So this I have written for your understanding. Okay, a little bit. So now you see that it's supposed to give answer for all the 3 ions: potassium, ferrous, and cyanide. But it doesn't give answer for
Aqueous. 4K aqueous.
but it doesn't give answer for Fe2 plus ion, Cn minus ions. That means the 2 ions are together. So this type of ion is called as complex ion. Hence, coordination compounds contains complex ion. If any compound, if it gives in the solution complex ion, either one or both cation and anion both are complex ion, that type of compound should be called as coordination compound. So potassium ferrocyanide, it's called as coordination compound because it gives complex ion. These 2 ions are together. They cannot be separated. That is why we are putting the square bracket. Both cannot be separated. On dissociation, these 2 ions are not formed in the solution. This type of compound is called as what? Coordination compound. This is a simple introduction, and then further we can continue. What is the coordination